Hi guys, this is Miss Bainey, and I'm just going to go through the data analysis with Logger Pro for the height of the Flagpole lab. So if you want to follow along at home, I can show you how to do everything. First thing I've done is I've put all of my distances in the X column, and I've put all of my corresponding angles in the Y column. And I'm first going to label this X column distance. So I'm going to give it the name distance. And the short name for that is going to be a lowercase d. We measured our distance in a unit of meters, so I'm going to go ahead and put that in. The data type is already numeric, so I can leave that. And I'm not going to generate values because I manually inputted values. If we click on options, we're going to have a place to change what the points look like and the color and how much precision is displayed. We're not really going to worry about that right now. What we're going to worry about is putting some error bars onto our data points. So this is the way you're going to record how much uncertainty is in your data, and you're going to save that in Logger Pro through your error bar calculations. So we are going to be using a fixed value. That's like an absolute error that we talked about in class. We're not going to be using a percentage. And for the distances, I'm going to do a realistic error of about 10 centimeters. If we think about measuring things outside, what we were really trying to measure is the flagpole to our eye. And since your eye is so far away from that ruler when you're measuring it, there's actually a whole lot more uncertainty in that than just the uncertainty of the precision of the instrument. So I'm going to save it as 10, and I want you to make something that's realistic for your distance measurements. I'm going to go ahead and click Done. And we're going to see that I have my distances right here. Oh, wait a minute. I clicked 10 and I put in a unit of meters, and that doesn't make any sense because really, if it's 10 centimeters, that's 0.1 meters. And so I can change that easily, and I can say done, and now that makes a whole lot more sense. After that, I'm going to come over to the Y column, and I'm going to double click on it. And double clicking on that is going to automatically bring me back to options because that was the last place I was. And I'm going to go back to column definition, so I can go ahead and give that a name first, and that's going to be angle. The short name for that is going to be theta, and if we use this drop-down menu right here, we can see that there's Greek upper and lowercase letters. There's also a degree symbol. We can pick subscripts, but I'm going to go for Greek lowercase, and I'm going to choose theta. There we go. The units for that is going to be degrees, and again I'm going to use this drop-down menu, and I'm just going to pick the degrees right there. And again we have numeric, that's fine. I don't need to generate values because I'm going to manually input them, but I do need to put an error bar calculation on that. So again, the precision of our instrument is plus or minus, probably, if we made it perfectly, 1 degree. But you guys made those on your own, and you were working outside where there might have been wind, so I want you to give a realistic expectation for your uncertainty. If I was doing this, I believe I would be at least plus or minus 3 degrees. So that's what I'm going to put in right there. And so we can see now that I have the distances and my corresponding angles. I have uncertainties associated with them right here. So the next thing in class that we did is we talked about how we could linearize this data by taking our tangent function and solving for tangent theta, leaving us with 1 over d times the height of the flagpole on the other side. And so what I really want to do is graph the tangent of theta on my y-axis and 1 over the distance on my x-axis. If you didn't understand how we figured that out in class, please come and talk to me and I'll be happy to go over it. So I'm going to need a column that is tangent of theta so I can make it on my y-axis. So the way I'm going to do that is I'm going to come up to the data column. I'm going to choose new calculated column. Manual columns are what we already made when we put data in. A calculated column is going to do our calculations for us. I'm going to call this column tangent of theta. Go ahead and grab a Greek lowercase from right over here. The short name, I'm just going to leave that as, tangent of theta. The short name, I'm going to leave that as tangent theta because that's not very long at all. Now there are no units on tangent theta. It's a ratio. It's unitless, so you can leave the units blank. And then I need an expression down here that'll tell Logger Pro what to calculate. You need to remember that you are smarter than Logger Pro. Just because you put tangent theta up here does not mean it knows what you want it to do. If we come down to functions, there's all sorts of different functions that we can use. We're going to go to the trigonometric functions, and we're going to grab tangent theta. And you can see it puts your cursor right in these parentheses because it's asking you what you want to take the tangent of. I'm going to take the tangent of the angle that I have, and I'm going to say done. So you can see I have a new calculated column where it took the tangent of all of the angles that I put in. But if you look at this column right off the bat, this doesn't seem to make much sense. You see I get a negative 45 over here. I have a negative 1. The reason is because LoggerPro defaults to radian mode. You're going to need to change it into degree mode. And in order to do that, we're going to click on File, and we're going to go Settings for our file. And right at the top here, there's an option for degrees and an option for radians. I'm going to change it to degrees. So there we go, say OK. And you can see now my data under tangent theta makes a whole lot more sense. OK, now I need another calculate column for 1 over distance. And so I'm going to come back to the data drop-down menu, choose calculated column. This is going to be 1 divided by d, or d to the negative 1. I'm going to make my name as 1 divided by distance. And that's not how you spell that. There we go. 1 divided by distance. My short name is going to be, let's do d to the negative 1, because it's really the same as that. I'm going to use a superscript, grab a negative and a 1. The units for this, because it's 1 over a length unit, is going to be meters to the negative 1, because it's really 1 over meters. So meters to the negative 1. And again, just because I told it that I want it to be 1 over the distance for the name doesn't mean LoggerPro understands the calculation. So I have to go through and say 1 divided by and choose the column that I want to use, which is distance. And I will say done. And so you see what I have here now is a tangent theta as an option for something to graph, and I can graph 1 over distance against that. Now, if you leave it like this, you can see your graph is kind of all smushed right here. What I'd like is for our graph to take up the whole area so it's easy to see, and there's a couple different ways we can do this. First off, if you put your mouse over, here we go, an axis like this, you're going to get a little squiggly line, and it's going to tell you it can click and drag and it can stretch your axes. So you can see I can stretch my axes up and down just by clicking and dragging, and I can do the same thing over here. But there's going to be a lot of clicking and dragging I'm going to need to do to get my axes where I want them to be. So I'm actually just going to want to put in the numbers that I want. I'm going to double click, and if everyone saw what I just did, I just put my mouse anywhere where there's white space, double click on that graph, and I get my graph options. So I can have labels, I can put all sorts of stuff in here, but one of the things I'm going to want is I want my y-axis to end at 0, and I want my x-axis to end at 0. So I'm going to say 0 for that right there. My x-axis, if I look right down here, if this is 2, 4, 6, 8, 10, it really doesn't seem like I go over 2. So I'm going to put the top of my x-axis to be at 2. And then if I look at my y-axis, I do go a little over 10, so I think I'm going to put the top of my y-axis at, I don't know, let's do 17 and see how that looks. There we go. So you can see now I get a nice linear set of data. My top data point is this one right here, and it's right in the middle of my graph, so maybe I want to stretch my graph out just a little bit. Be careful that you don't stretch your graph out when it's a squiggly line with arrows on both ends. That'll move your axis up and down, and you don't want to do that. What you want to do, and let me just get the 0 back there, what you want to do is move it like this. Just kind of stretch this up a little bit, move this a little more towards the top, and do the same thing over here. There we go. So now you can see I have a nice big graph. It shows my data very nicely. Now, I made up my data just by plugging into the tangent function. I did not actually go out and measure data from the flagpole. If you measured your own data, you may see that when you get really far away from the flagpole, your data points may start to curve one way or another, and that most likely is due to the slope of the ground outside. If you find that your data is influenced by an outside factor like the slope of the ground, we really don't want to use that data to then calculate the height of the flagpole. What we're going to be able to do is just strike through that data. I don't want you to delete that data completely because all data points are important, but let's say I didn't want to use this data point right here when I did my calculations. All I would do is I'd highlight it like so, and you can see that it highlights it in my data set right over here. Then I can go up to Edit, and I can strike through that data cell. And it's going to keep the data. I can still see what I recorded, but it's no longer going to use that data point in calculations, and it's not going to show that data point on the graph. You can see that it's gone from the graph. So that is a real quick overview of what we did in class for the Height of the Flagpole Lab. I'm going to post a few more videos just to show you a couple other things that you can do with the Height of the Flagpole Lab, but I hope this was helpful, and come see me if there are any questions. Thank you.